All right, folks, welcome to Privacy Pass at IETF 120. Could I get somebody to close the back door just so we reduce the noise coming in? Thanks. Um, so here is the usual note well, which kind of describes and provides references to the kind of policies, operating policy of the IETF, including IPR policies and what your participation is expected of your participation. So it's good to be familiar with that. You will see this many other times, at least once in each working group meeting you go to. And just also remember that we want to have productive technical conversations here and want to avoid behavior that isn't conducive to good working group participation. So please, if you have concerns about this, you can talk to the Ombuds team if you feel that there's been problems. Next thing, please sign in through the on-site meeting tool so we get an accurate record of the number of people who are participating, and also so that you can join the queue if you happen to want to comment on one of the presentations that we have. Thank you. Also, remote participants, it's good to keep yourself on mute until you are ready to present. Here's some additional resources which you probably have already found if you are here. Okay, we have a relatively full agenda. We'll talk about rate limit tokens, metadata. Then Watson will talk a bit, give an update on BBS signatures, and then Paresh will talk about EPPT. Are there any additions or corrections to the agenda?
I want to note that this agenda has been slightly modified from the version that is in the data tracker. So we will try to remember to go update it. We switched the order to put the presentation on rate limit tokens first. Is Tommy Polly here in the room? If not, we may have to go back to the originally planned order.
All right, yeah, so we'll adjust as accordingly. Next thing I do want to note that we did have 3 RFCs published from this group. Thank you all for your hard work. This is a great milestone, so. All right, Ben, did you want to say a couple words about reading?
Yeah, I just wanted to thank everybody who participated in the working group last call for rate limit tokens as an experimental draft. We got a lot of deep reviews and thoughtful feedback there. And I really appreciate everybody who took the time to contribute to that. The chairs have decided not to close that working group last call as originally scheduled. We're going to hold it open for another week after the after this conference is over, so two weeks more, and we will, I think, hand it right over now to Tommy Polly to talk more about the rate limit tokens draft and the feedback that they received from all of you. I also want to remind our speakers that we only have 60 minutes total, so we are going to try to keep this tight and on schedule.
Slides.
They should have them now.
You changed the order. Okay. Hi, everyone. Tommy Pauly talking for the co-authors on the rate-limited token issuance protocol. Go quickly. So we recently did kick off a working group last call on this. The document had been kind of sitting, chilling, in a stable state for a while. So we're like, okay, let's get done with this. There were a bunch of pieces of feedback, which were good to hear. Some of them were that there are probably better and simpler cryptographic options for getting per origin rate limiting what we're trying to do. And as a reminder, this particular draft is taking the publicly verifiable RSA blind signatures as the base and then adding fun OPRFs around it to like hide the origin name so you can do per origin rate limiting that is hidden from the attester, and like it's complex, but it works. There are questions that were raised around the fact that we'd moved this to experimental. I think a good point is like, what is the experiment? Which is well taken. I think we could potentially discuss ways to phrase it that way, but maybe that's not the right thing. And then also there are some issues that we filed out of the last call. Thanks, Chris, for filing the issues based on the feedback. That there were places that needed some clarifications about all the roles and how they're interacting, because it was clear from some of the comments that not all of the interactions were obvious to the reviewers. Okay, so that's the type of feedback we got. One thing just to drill in on the other different approaches. I think we definitely, as the authors, agree that there probably are fancier, cooler crypto options that one could do to achieve some of the same goals. This was really born out of like, let's have a very pragmatic approach that's using existing primitives and essentially ends up putting them together in a more complex way as opposed to using something that's more novel crypto. So that's the background of how we got there. So I'm going to talk about some of the ways forward here. I do have one more slide, so I'm going to talk through all the slides and then we'll have input on it. So there are different things we could do at this point. Like clearly, it's not ready to progress, or we may not want to progress it. So option A, we could try to fix up the document, add the extra clarity, maybe work on editorial things, do the revisions, and then eventually move to another working group last call. That could be experimental. It could be proposed standard, depending on how we're feeling. So we could just keep working on it, keep trying to improve what's there, but fundamentally keep this cryptographic basis, because it is a thing that can work. It's a thing that people have implemented. So we could do that. Option B is that we could just put the document on hold and say, you know what, we want to do something that's fancier, different crypto. We don't like the complexity here, even though we may want to do per origin rate limiting, and we'll just wait and then kind of gut the document and replace it with something cooler when we have that, but still kind of leave an adopted item for rate limiting. Or we could just abandon the whole thing and say like, forget it, we don't like this, and maybe something else will come along. That's the general menu that I see. If people have other things on the menu, come up with your own emoji. But the one thing I want to point out is that there is a bit in this document that is actually, it's a pretty boring bit, but in use of normal type 1 and type 2 privacy pass recently, because for various reasons, we and others have been actually using them more in various deployments. There's a piece that's from this document that would be useful to have outside of this more complex new cryptography scheme. And that's specifically around when you have a split issuer and a tester, having the communication between them that is influencing rate limits. So this is a case where you have, a client is talking to an attester that is doing some device or account verification to say this is a legit thing, but the actual tokens are being signed by a key that's owned by the third party that's related to the thing that's going to be verifying the blinded tokens. And the tester's job and what it's good at is validating clients, but there are a lot of aspects of the policy of how many tokens should a given client or any client get for this token that's really owned by that token issuer, or essentially like the origin that's verifying things. And so there is a mechanism that we defined for this document, which is kind of buried in section 5.5, that talks about a header that is used on the flow where the attester has asked the issuer for tokens, and then the issuer says, hey, here's a token, but please enforce this particular rate limit. And right now it's expressed as like a simple integer of saying like, for my policy window for this, be it this day or this hour, make sure, I don't know who the client is, I don't know how many clients there are, but make sure you don't give any client in this time window more than 5 tokens. And what's nice about this is that it's a fairly dynamic way to communicate a rate limit. It means that like the issuers can say, yeah, maybe I want higher rate limits on certain times of the day, off-peak hours, and on peak I'm going to be more restricted. Or like they can have broad time-based policies that are really not specific to clients. So it's a useful thing. I think it goes beyond this. So even if we decide put this on hold for the overall mechanism, drop the document entirely, I think there is work to do around rate limiting that we've learned from experience goes beyond trying to do per origin rate limiting and gets into just generic rate limiting for like normal PrivacyPass tokens. Okay, so I'd love to hear feedback on what we should do and what people think about this bit of mechanism. That's all. What do we do?
Stephen Valdez, Google. Of the ways forward, I think probably CAB. I'm worried that if we try like putting this on hold and replace it with some other crypto, like we won't know exactly what the shape is. Trying to like get it to fit into this like sort of tortured shape that the draft is currently in, and like the use cases, if I know there's the BBS proposal, like might be too complicated, and maybe just start from scratch, and we can always like look at this draft from the like GitHub if we ever need it. But I think like without strong like experimental plans, like I think A just means we're going to be stuck in this state forever.
Watson.
Hi, Watson Lad, Akamai. I really think that A is possible. I think once we write the text to really make clear to a reader what's going on, and especially sort of clean up the description, the cryptography, it'll be a lot easier to get agreement that, yeah, this is something we should try out and see how it works operationally. I think that's what's missing right now.
So you're saying A of like try to clean up the document?
Yeah, I think a lot of my comments stemmed from, I look at the thing, I try to read it and understand it, and it's difficult. It's sort of there's whenever you're writing down this thing, I've done this too. There's things that are clear to you because you've thought about this problem the whole bunch that are not clear to the reader.
Yep.
And that are reflected in how you write. And I think once that's cleared up, there'll be a lot more of a case for moving it forward.
To the point of the next slide, and since I know you're looking at BBS and other things, do you think it would be useful to try to separate out kind of non-token type specific communication formats for expressing rate limits?
I'm really not sure.
Okay.
Because I think we'll talk about BBS later, but there the origin is really dealing with the rate limits entirely, and it's not part of the issuance process, or not really part of the issuance process. So I think there isn't as much of a need is it useful for the issuer to convey information to the attester about things it wants the attester to enforce?
Right. Exactly.
Possibly
Exactly.
in general, but I don't really have a good grasp on the split issuance case. Maybe you need information like these are the green iPhones. Don't attest to them the same way as you do the red ones. Because I'm going to assign a different token based on the answer you give. That might be another application of this kind of signaling.
Right. Although you want to limit the potential fingerprinting you can get from that. But yeah, understood. Yeah. Okay. Dennis.
Yeah, Dennis Jackson, Mozilla. So I think I kind of agree with whatever the authors want to do. Like, if there's energy to do one of these things, if there's like, oh, we think this could work, if we have this experiment in mind, we want to do it, then I think that's persuasive. If there's not energy to do that, then I would say that maybe C, B do look like the right things to do. Like, rip out what you need, move on is not the worst thing to do. But it's like, are you going to spend energy polishing whatever that becomes?
So I mean, certainly. So I guess what I would say is like, to the point on the next slide, like I would be very motivated to try to pull some of this out because I've seen it be useful. And I've kind of told people like, hey, do that header without doing the rest of the document. So I think there's use for that. I mean, as one implementer, like, we've implemented this. So like cleaning up A is useful. I think, part of the reason we had said, experimental, and I think, maybe that's a mistake for how it was put there, but it's like the ways you may want to use this, like, trying to apply this to the web would be experimental, but the mechanism underneath, it's like, yeah, it's a mechanism. Maybe it's heavier weight than what you need for some applications, but if you have an application that wants to do this, you can do it. And we think it is fit for purpose, even if they're going to be better things that quickly succeeded.
Yeah, I feel like as a signal for the others that come later, they kind of need to know at first glance where this landed, whether this landed as like something we were just never sure about, or where something that we actively stepped away from. Like, it's a useful communication.
Mm-hmm. Mm-hmm. Okay. Anything else? Okay, cool. So we got mixed feedback, not all one direction. So I think the authors can chew that and essentially decide, what do we have the energy and appetite for going forward. Cool. Thank you all.
Okay. Thank you, Tommy.
You got the slides?
I will ask slides. I've never used the
Should be just about. There you go.
Cool.
Hi, everybody. I'm Scott Hendrickson. I'll present on PRIVACYPASS extensions today. We've done this work with a bunch of people, Chris Wood, Gauss, Kevin Yost, Stephen Valdez, also Tommy Quality. So lots of people involved in this one. First, I just want to give a reminder of what we have adopted into the working group so far. So 2 drafts. There's the auth scheme extensions draft and the public metadata issuance draft. Auth scheme extensions is very simple. You'll see it's a very short draft. It is essentially just adding a new extensions field into the existing authorization header. We'll talk more about that a bit later. And then the public metadata issuance draft is a bit more complicated. In this one, we're defining 2 different variants that allow attaching public metadata along with tokens. One is a POPRF, which is privately verifiable, and one uses partially blind RSA, which is publicly verifiable. And I lost my connection, but I'll get it back. There we go. Nope. Cool. So I just wanted to call out how we're using this today. So currently Chrome IP protection, all the use cases that I'm going to call it here are with public metadata. We at Google are not using the POPRF model. We wanted public verifiability. So Chrome IP protection is using the public metadata for all of our authentication in that project. The Pixel VPN also uses this for the authentication model. Additionally, since the last IETF, we did a third-party audit, which is now published, of the underlying cryptography. We'll talk a little bit more about that at CFRG. I would encourage you all to attend there as well, because we will bring up that draft for the public metadata. But feel free to click the links in the slides and you can check that stuff out. Last IETF, we got some feedback around how extensions should be negotiated. This is good feedback. We didn't really update the drafts to reflect the ideas here, but I wanted to kick off some conversation around this today. Just to kind of review, we are currently negotiating the token challenge by, well, I'm just going to follow the diagram here for you all. A request heads out to the origin. The origin provides a token challenge back indicating a token type. That token type is indicative of what cryptography is going to be used. So if I'm going to use DA7A, I believe that one is encoded to the POPRF model, and DA7B is the blind RSA. Maybe it's flipped, but that's conceptually the idea. Then a client just kind of has to know what extensions today, and how we specified it. A client just has to know what extensions it should provide to the origin. So it kind of is just basing that on the combination of what token type it's seeing and the origin it is talking with, or maybe the context that it's using this token in. That was considered a bit awkward, and we had some discussion about this in the last IETF. Really, the discussion centers around, should the client be able to, well, first know which extensions the origin is going to expect to see. And then the secondary question is, should the client be able to provide a subset of those extensions that the origin is requesting? The reason that we didn't standardize this initially was we were worried about providing more overall entropy into the system that could make the client more identifiable. So for example, say an origin, say we did have some way for an origin to provide saying, I want you to send back extension 1 and extension 2, but the client only provides extension 1. That could be entropy that the origin can then kind of subdivide its population on. This complexity was something we didn't want to take on initially, and so we chose to, in the auth scheme extensions draft, not add any ability for the really any change to the token challenge. We are only changing the private token today. That's something that I wanted to discuss, and we will definitely discuss that later today as to whether we should make a change here. I actually believe in the next slide, I do have a concrete proposal. This is very high level, but we're happy to write this up in a draft as well, around how we would do this extension negotiation if this was something we were interested in. Essentially, we would modify the auth scheme extensions to additionally support challenging for, or letting the client know which extensions it is requesting. And then the client could provide one or possibly a subset of those depending on the deployment in the extension fields itself. So I didn't indicate that here in the draft, but the extensions equals DEF could encode extension type 1, extension type 2, or both. Yeah, so we'll discuss more of that in the discussion section. I also wanted to bring up, we didn't have a lot of feedback on the draft since we adopted last IETF. So concretely, we're wondering, what should our path to working group last call be? This is kind of a proposal that I've laid out. One thing I would like to see done is make sure we get the partially blind RSA cryptography adopted into the CFRG, or we find a different path to adopt this work. We did previously present this in the CFRG, I believe at 116. but it was not adopted because there were no drafts depending on it that were adopted in other working groups. Well, now we have that. We have this adopted in working group. So it's time to go back. And we will be presenting that. Gauss will be presenting that at the CFRG on Thursday. I'd encourage your participation there. Hopefully we can get that adopted this IETF or shortly after. And then the other major thing I wanted to talk about is what we're going to talk about today is the extension negotiation, or choose to keep auth scheme extensions as is and not negotiate extensions. I did leave a bonus in here, which is we could choose to adopt the expiration extension. I don't see this as a hard requirement. We talked about potentially adopting a few different extension types over the last few IETFs. Every deployment is going to need its own custom extensions as well, or I think it's likely that they will. But certainly it is nice to provide at least a model for people to build off of in terms of looking at extensions that are in use. It seems like expiration does have some general applicability. And so I would like us to discuss whether we want to adopt expiration extension as well. I'm going to back up off of this slide, back to this slide. And with that, I would like to open it for discussion. All right, I'm going to mine for participation. All right, there we go.
Chris Patton, can you clarify the entropy is bad situation?
Yeah. All entry is bad. Don't we know that? So essentially here, when an origin has challenged for extension type 1 and extension type 2, one option for this particular deployment is to say that I require both extension type 1 and extension type 2. If you give me less than that, I'll just not accept your request or reject it. But another option is we could specify and say that the client could provide a subset of those extensions. And that's the case where I'm worried about subdividing the metadata set or the entropy, creating more entropy, excuse me, where we'd say if I'm only providing extension 1 and the origin accepts that, we've now allowed the origin to subdivide the population into at least 2 sets. If 1 is optional and number 2 is required, the sets are you provided 1 or you provided 1 and 2.
So it's just a way of possibly de-anonymizing or partitioning the set of clients into
That's correct.
Smaller anonymity sets.
That's correct.
Okay.
In the I think it's the partially blind, no, the public metadata draft, we discuss how metadata itself can be used to divide the population. And this is another example of more metadata that could be used to divide the population. So we need to go and update to make sure that that is fully described.
Tommy Polly Apple. For the negotiation question, I think I'm inclined to agree with you that we shouldn't define it here and now. You're looking at the auth scheme RFC, we do call out that different issuance protocols and therefore different token types may define other parameters that go in the token challenge. That could be required, that could be optional. So I wonder if it makes more sense to have different token types or essentially different documents define more targeted and specific token challenge parameters, that instead of saying, here's all the possible extensions and whether or not you can combine them, they could express, oh, I actually do have a valid use case that we could analyze independently, that like I need to differentiate what extensions you need even for this one token type, and then you express it that way. But we do an independent analysis for that. So that's just backing up, I think, your conclusion that you already had. For the other question about adopting the expiration one, that sounds good. I would like to see us have one concrete adopted extension mechanism here. That's not just like some people have some proprietary way to use this. then we don't have a way of talking about it publicly that's like, here's how you actually hold an extension and use an extension.
Yeah, I agree. Just as a reminder for the group, one other extension that we considered adopting was GeoHint. But I think we didn't want to really try to standardize on the particular fields of geo, and that's a difficult question. And so expiration is something we can all kind of easily agree on. Nick?
Nick Doty, Center for Democracy and Technology. I think the important thing would be to have the important thing about having in-band negotiation of extension parameters is that it lets us actually in the working group evaluate the privacy implications of a policy. If it's just, well, the client just has to know some things about some origins, I actually think you're going to have all the same privacy problems. It's just, it will just be in some proprietary system where clients know things about origins. Maybe they have optional parameters. Maybe we'll never know. But I think you'll have the same privacy problems. They'll just be proprietary. So it would certainly help someone who's trying to do reviews of the privacy properties of these specifications. And I think it would help that working group in trying to like actually demonstrate interoperability of extensions if we had in-band explanation of the policy from the origins about how to use extensions, and then we can evaluate their privacy properties. I think that might still be consistent with what Tommy just said about it should be specific to each extension. And yeah, maybe some extensions do need this or some token types do need this certain, well, there's these two things are optional or something, but I think it needs to be described and interoperable, and then we can actually evaluate the privacy properties of it.
Yeah. I mean, to me, that sounds like it's less about extension negotiation and more about in each extension having a method to specify, how that extension changes the entropy of the system. I wonder if that is somewhere where we can make some concrete progress, because of course deployments are going to have their own private extensions. But if we did, in the process of specifying an extension, like expiration timestamp, for example, also specified precisely how the privacy parameters are changed with the different fields and how they change, that might be a useful step in the direction that you're looking for here.
Yeah, I guess I'm expecting that if we actually define this, it would not just be these extensions are possible, but also like these are the things that I require if you use this extension.
Right. Yeah, and then another thing that I would note here is like extension negotiation. I think it might just add more complexity into that. It sounds like we still want to settle on the basic privacy parameters of each extension. If that's the feedback I'm hearing from you correctly. And so, that is definitely, I think, a problem that we should scope first prior to moving towards extension negotiation.
Jonathan Hoyland, Cloudflare. I don't really like either of these options because I don't like introducing more entropy, but I also think the option of you must have all the extensions means you've basically guaranteed immediate ossification, and there's just 0% chance that anyone will ever be able to deploy a new extension. And you'd end up with this horrible oh yes, in 5 years' time, we need Greece extension negotiation for, I don't know what the right answer is, but both of these seem very horrible.
Mm-hmm. I think it's not that extension negotiation is not possible, to Tommy's point. It's just being left unspecified at this point. And we have to decide whether that should be specified in this particular, basically in off-scheme extensions, or somewhere else.
So it's more, is doing it at all a good idea? Is my yeah, I don't.
Doing what?
Having extensions actually probably is the you're going to end up with just like have the token type include whatever extensions, and you just define more token types.
I feel like they're all solutions in a similar space, actually. Like whether your token type itself expects a certain set of extensions, and then you increment the token type version, or whether you're just adding a new extension. Ultimately, client code needs to support either of those cases. So I think we're all iterating in the same space here.
But yeah, the extension negotiation thing is going to be so painful to actually deploy in without getting ossification.
Okay. Thank you, Scott. Thank you, everybody who brought comments.
Thank you.
Next up is Watson.
Okay, I think you've got the slides, but I'd like to control them. So I entered the queue so you can make that happen where I click the thing to control them. I think that's how it should work.
I think you have to request access to the slides with the little, there you go.
Great. That has just popped up for me over here. And that's the one. Great. Okay. I think I'm all ready. All right, so I'm going to talk about PRIVACYPASS and BBS. I've forgotten what the B's stand for. It's Untitled, I think. And this is work with Michelle LaRue, and many others have contributed over the past months and weeks with helping understand the problem we're trying in sort of space where we're trying to work. So in the beginning, we had PRIVACYPASS. It was really simple. You got a token. All the tokens looked the same. And when you needed to go do something, like in this case, get past a CAPTCHA on the same network that gave you the token, you handed it right back in. And the cryptographic analysis was pretty simple. And it solved the problem. So worth doing. And if that was all we needed, we wouldn't be having this working group anymore. Because now we've wanted more. So picture on the left is a more complicated kind of token. It's not just saying you paid your subway fare. It's showing additional information about why you're entitled to it and when. I don't think there's an expiry date on there, but there's some additional fields. We want rate limits. We saw that in the previous presentation. We want additional metadata. And once you have additional metadata, one of the problems that you run into, particularly in a more complex deployment situation, is when does the issuer start adding that metadata? And if there's if not all clients need the same metadata to or not all origins need the same metadata to make their decisions, do you always send the union of all the metadata they could want? That has a real privacy cost and could keep you from having a useful implementation where selective disclosure could solve that. Issuer blindness has come up. That's where I'm an origin. I trust these 6 issuers. Show me a token from one of them. But I should not be allowed to know where you got that token from. I just want to know what's on my list. I don't want to know where it's from because that might partition the set of clients. You might want longer term pseudonyms. That's a thing that's come up in the literature before for stuff like Tor, where you don't want to have people spamming blogs, so you want something that's kind of like IP, but not really. Our solution, B'nai Shachtam, you need to modify it a little. You need to add in blind issuance, which is basically prove that you constructed your commitment correctly. And linear proofs. We want to prove things about the information that's in the token. This gives us selective disclosure and rate limiting very nicely. Just do a little proof for the rate limit. Show that you've made some ticket. It's a function of a thing. Cost, 1 pairing product, so not that expensive. And then usual linear proof. Issuer blindness. Not so sure of the costs, where we know we can get it. Just need to think through the exact details of how you get it efficiently. This lets you get one token and use it a bunch of ways. So if you have the issuer set up to issue a token that can be used for all these things, how it gets used in the wild is up to the client in the origin. There are corner cases to consider. If you're issuing a new token every month, well, you can't have a rate limit more than a month. That's stuff to think about. So where are we with this? Well, we've got a demo written out. I need to write a draft. There's some thinking through, some little details to work out, little technicalities. I'm pretty confident they're resolvable. It's stuff like check the matrix has the right form. And then the big questions. Are people interested in this? What are the applications I'm not thinking of? I'm happy to use the rest of the time to go into more details. That concludes the presentation.
Chris Wood, on the "we wanted more" slide, can you say a bit more on where these sort of requirements came from? My understanding is that it's like the privacy pass on the web, private state tokens sort of mental model, but I was wondering if you had something different in mind.
Well, I'll be a little glib and say ask the previous two presenters who each wanted one of these. Right, why do you, so privacy pass on the web is a big motivator, but there's also a function of every time someone wants another feature, we go write the RFC, we go write the cryptography, we go check it, we argue about the properties we want, we do this again and again. And if you want to combine two that have already been done, you got to do it again. And, you know, it's funny that we've had to do this twice.
I agree. I think, you know, finally solving all these in one clean, elegant way is the right answer. I was just sort of curious as to like what your motivation was for this. As to the questions later on, I think, yeah, I'm interested in the space. Happy to help work with you on it, be a BBS or something else. Having, you know, moving away from something that's like a token and more towards like a credential, something that's multi-show, something that has these other desirable properties. Is something that I think this group should start thinking about and taking seriously. I'm very pleased to hear that there's like ongoing cryptography work to help enable that. A little bit sad that it's going to slow things down because it's going to have to go to the CFRG, but that's just the way we work. But or maybe we do it all on Privacy Pass.
The CFRG dependencies are light. It's slight modifications of stuff that's there. I'm talking to some of the people pushing stuff forward there. But you're right. Well,
is it like such that we could avoid the CFRG? Great. Thank you.
Okay, Kosei.
Okay, can you hear me? Thank you for your fascinating presentation. I am Kosei Akama, a master student at Keio University. This topic is particularly interesting to me, and I would like to contribute if possible. I have a question. Do you have plan to discuss and adopt other BBS-based rate limiting schemes? Many BBS-based rate limiting schemes, generally known as KTAA, have been proposed, each with unique characteristics. Including your powerful proposal shown in the mailing list, these schemes have trade-off in some aspects and fit different use cases. For example, some use cases prefer a scalable KTAA up to the max of K, and others prefer KTAA compatible with their existing secure hardware. To cover wide use cases, I think it would be beneficial to survey, compare, and discuss several existing KTA primitives and then discuss their interface for them. I would like to know your thought on this. Lastly, I apologize for my limited English listening skills, so I will understand your answer after the minutes is logged. Thank you.
Far better than my Japanese. Yeah, I think that would be interesting to send to the list. Certainly the scheme we've adopted is, you know, sort of ad hoc. If there's stuff that's out there that maybe has slightly better features and is still compatible with the overall picture of the anonymity proofs, I'll be interested. But I think that's the sort of thing where send an email to the list would work.
Thank you.
Yeah, +1 to Watson. I'd like to see more generalization of this stuff. But to Chris's point, oh, my name's Chris Patton for the people on the thing. I forgot my question now. Wait, no, I remember it. Hold on, just give me a second. Oh, what are the bits that are like we have BBS? Don't we have a pairings thing that we can use at CFRG? Can you just enumerate, like, for the scheme that we have right now, what are the things that we would have to specify still?
Yeah, so the BBS draft, there's a number of things at CFRG. The big jump is that you need the signer to not sign the messages, because if you sign the messages, you'll be signing, they would have to know the secret key. You want them to sign the commitment to the messages, the product of all the H's and M's. And that's easy, that's a small change. And then you want to be able to say, I do BBS and simultaneously I prove some linear equations involving the same exponents.
Thanks. I just want to +1 to Chris Wood's point. Like, I think multi-show is very interesting and probably the future. I think metadata obviously is cool. I think we may have difficulty, at least speaking from my experience, we may have difficulty deploying pairing-based protocols. And so I'd like to see possibly some alternatives, especially for multi-show, which I don't think we have a good alternative for yet, proposed with crypto that might be more readily deployed. Thank you.
I would like to understand better the perceived difficulties here. I think when you get into things like blind RSA, etc., you really, if you're being honest with everybody, you'll be running into some of the same difficulties. It's not the same thing as RSA, PSS, etc. But I do want to see something that's deployable. I do think for multi-show, it's a tall order, though.
Tommy Polly, Apple. So overall, yeah, I think this is interesting. I am happy to see more options proposed that solve different problems. I mean, to the point about things like blind RSA, even if ultimately maybe they have similar complexity levels, I think part of it's just like we see, many more implementations of blind RSA. So it's just like the practical implementation barriers. And when we have a growing set of new options, which ones are different platforms actually going to implement and deploy, and what's going to be worth it to them. All that said, I think for this group, like where we are right now, I think it's a positive thing if we end up with a broad range of token types and token approaches with different crypto, and we kind of see how they can be held differently because they'll have different trade-offs and different properties. And so I think, yeah, let's explore BBS. Maybe other things will also come along, and then it's okay. We have room in the registry for that, and maybe we'll want to have a more constrained set for what we would say you should use this for the web, and maybe that's going to be a subset of these things. But just defining the mechanisms, I think, is useful.
Thank you.
Stephen Aldous, Google. I think I mostly agree with Tommy's point, though. I think like we have on your slide with like all these cool requirements that everyone's asking for, like I think it would be useful to like nail down like specific like people who are going to experiment with these specific things, because like if we build a bunch of different token types that no one's going to use these features, like we'll just like come back in like 4 IETFs and like say that no one's supporting the WGLC. So I think trying to nail down like getting some commitments that people are going to play with these token type experiment them, I think is core. To the point that Scott had, I'm curious if like you've been seeing other platforms beginning to pick up BBS style things, or like if that's still in the early stages.
Well, I mean, there have been TPMs have deployed pairing-based crypto for decades.
Dennis Jackson. I'm pretty excited about this, and I think there's a lot of interesting opportunities that extend beyond PrivacyPass for some of this core BBS plus stuff that I think are maybe unappreciated. Like especially in the wonderful world of EIDAS and the EU kind of digital wallet stuff, as depressing as much of that stuff is, there's some people looking at BBS and related things in that space, and like it's clear that something of some kind is gonna happen here, and it might as well be good. And I think the most exciting thing I've seen from like Watson and Michelle and co is some really nice innovations in bringing stuff together to actually tidy up a lot of difficult and complicated literature, and also to like give us properties that we know that we need in the real world. Like things have actually got to be pretty much one round trip. Things have got to be really post-quantum kind of statistically secure. We don't want to have a privacy risk from the whole PQ setting. And like, I think this is worth the time to really explore and figure out if there's something we can really invest in. So I think it's really cool.
We have maybe one more minute. So if yeah, I'm going to unlock the queue, but please be brief.
Thanks for opening the queue. I wonder if we should maybe take a little bit of a step back and ask ourselves what are the sort of ideal properties we want from an anonymous credential-like scheme without making specifically of it being a BBS-like solution. Because there are other ways to build anonymous credentials that don't require pairings and don't require such a big lift to new cryptography or to existing cryptography libraries. Like use algebraic max or something like that. That they have different properties. Like they're not publicly verifiable; they'd be privately verifiable. But again, this is just a trade-off that comes with choosing different cryptography. But I think it would be a useful exercise if people who are like interested in experimenting in this space came together and thought about, okay, if we had a credential, what would be the ideal properties that we want from such a credential, and then maybe like jump to the solution after that. But not to say that this work should pause. Please full steam ahead as fast as you can. But I'm wondering if people would be interested in that exercise.
Yeah, I absolutely agree. I mean, public verifiability isn't something I didn't put on the slide. It's one that drives unique pairings.
Exactly. Yeah. So if we're willing to compromise on that, perhaps we would have like potentially simpler cryptography that wouldn't scare people.
Okay. Thank you, Watson. Our next presentation is from Paresh. It seems like there's one more comment on this. So while you're stepping up, let's see if we can squeeze in one more comment.
Thanks. It's Kalia Young. I couldn't get in the queue. I just want to say, please consider looking at the work coming out of the decentralized digital identity community around BBS Plus and credentials so that you're at least aware of that work and it's complementary. Thanks.
Yeah, I've looked at their drafts and we are in contact.
For the notes, can you repeat that acronym or that decentralized what?
All right, thank you very much. My name is Bart, this is Paresh. And we'll be very quickly taking you through how we propose to use PrivacyPass in EAP, Extensible Authentication Protocol. Privacy is also a thing in networking. We've done MAC randomization, so anonymized device identity. We've done anonymized application identity with application proxies such as MASK. And the third leg to this tool is user identity. And the protocol that's used to provide user access to networks is the Extensible Authentication Protocol. So Paresh and I, we looked at, okay, where do we see identity leakage or privacy issues in EAP? And we basically see that, identity can be used, by networks as well as by AAA to potentially share personal information for marketing purposes, share that with third parties, track location also, combining location technologies with identity, basically monitoring, surveilling employees, students, and visitors. EAP is transported over radius and diameter, mostly radius, really. And what we see there also that there's attributes that can divulge personal or identity information, such as chargeable user ID, username, location for specific attributes as well, RFC 5580, for example, and then attributes also that can infer location, such as NAS IP address, NAS identifier, operator ID, and so forth. Every EAP method also typically does its best to preserve privacy, but that's typically focused on passive or active attacks by third parties, and not so much the access or the network service providers and the identity providers themselves. So we wanted to give you an example that we've kind of personally worked on. This is the Wireless Broadband Alliance Open Roaming. It's a standard that includes a privacy framework. So there's a document with privacy guidelines, how networks and identity providers have to implement privacy protection for end users. However, 2 IETFs ago in the hackathon, we kind of looked at how different identity providers implemented that, and we did find some intentional or non-intentional issues. For example, chargeable user IDs that need to be anonymized in open roaming were often not rotated fast enough, so some correlation was possible. We saw one instance of identity leakage in class attributes, and obviously identity providers could also use the attributes that we just talked about to infer user location. So conclusion here is that even if you have a privacy framework with guidelines, unintentionally privacy leakage could still happen. Next slide, please. So our objectives, for using PrivacyPass and EAP were, basically getting anonymous access to public and private networks and to protect against active and passive attacks, but also unintentional or intentional privacy leakage from network service providers, venue owners, enterprises, and identity providers. The core principles obviously should be very, very familiar here to the folks from this working group. Obviously, we want to carry attestation instead of identity, and we want our authenticators to be unlinkable. I'm going to hand you over to Paresh now, who's going to explain exactly what we do.
Thank you, Bart. Hi, Paresh Sawan, Apple. So we have a problem statement and we have objectives. So how do we actually find a solution to the problem? So based on the problem statement and what we wanted to accomplish as an objective, we felt strongly that we need something which is unforgeable, unlinkable proof of attestation. And that makes PrivacyPass token as a very natural choice because it has those properties to offer here. Unlinkability is the most important one, and that's exactly what we are looking for here. And the use of PrivacyPass token in the EAP PPT protocol does not change the original specifications that are rolled out by the PrivacyPass working group. The EAP PPT protocol is just very similar to HTTP authentication scheme that uses PrivacyPass token. It's a different protocol messaging which is still doing same challenge response or either layer 2 or layer 3 when it is used for VPN purpose. So here is the diagram or a sequence diagram that shows at high level how the EPPT works. And for presentation purpose, I have shown here the issuance is occurring at the same time that EAP session is happening. So just like the PrivacyPass HTTP authentication scheme takes place over HTTP over TLS, here also the EPPT is being executed inside the TLS tunnel provided by the outer tunnel-based EAP method. And there are various tunnel-based EAP methods that offer TLS tunnel, which is server authenticated. And once we establish this TLS tunnel, it invokes the EAP-PPT authentication. It obviously starts with asking for the identity, and here the identity response carries a privacy-friendly identity. All that it needs is the identity in a NAI form, which is only carrying the realm, which is required for finding out what is the corresponding token challenge for this client, and also what should be done for redemption flow for this client. So once the identity is determined, it sends the token challenge, and this token challenge structure is very similar to what we already have in a HTTP authentication scheme document.
I think we should move to questions as quickly as we can. So let's see if we can wrap up the slides and get to questions.
Okay. So yeah, so essentially this is challenge and response protocol. The challenge is still using token challenge, which has all the members of token challenge structure. The origin info is the only one, because here we are not talking about any website or any proprietary web service. So origin info here could be the server certificate carrying a subject alt name extension with a DNS name value, and that could be actually used here as an origin info, so that the token can be actually bound to that origin info, which could be multiple origins here. And then the issuance, again, it has to go through the attester. The client has to prove that it is worthy of the issuance of token by providing some evidence of attestation. And then once the attestation is complete, then issuer issues the token, and that token gets verified by the EPPD server, and then whether it is OPRF or RSA blind signature, which means either privately verifiable or publicly verifiable token. So that's pretty much all. Yeah, question.
Okay.
Yeah.
Questions.
I mean, I was thinking through the deployment. First off, I think this is very interesting application of PrivacyPass, so very neat. I was wondering, as I'm not a Wi-Fi person, I don't know if this is a big problem, but I was wondering if you have like in networks that are deployed in production networks, the reason that authentication is there is either probably to protect some valuable resource, maybe connectivity to a particular thing you don't want normal users to connect to, or potentially so that you can ensure that a user is continuously meeting your network policies, for example, and you could kick a user off in the long term if they're not. Have you thought through whether this type of protocol makes those challenges more difficult? Or is there a different use case that you're thinking of for this particular protocol that I'm not thinking of?
I think the use case is still same. The protected resource here is the network connectivity and network access and internet connectivity, which can be granted to the user based on the anonymous credentials that is presented using PrivacyPass token. So whether you're accessing a proprietary service or network, I don't see actually a reason for service providers to actually know the identity of the user to grant an access to the network. Whether it is a wireless, wired, or a VPN. Even actually in the enterprise network case, we could think about using a privately verifiable OPRF-based solution there, where the enterprise can determine the validity of the token using a private key of the issuer, and without knowing the real identity behind it. And then to access the enterprise applications on, when are you working on an enterprise environment, there are actually other mechanisms that can actually allow you to access enterprise applications like OAuth or whatever. So we don't need actually, a network access to determine the user's identity. And that's where actually the PrivacyPass token is very instrumental.
Tommy Polly Apple will go very quick.
So I think overall adding better privacy for things like open roaming is very important. So I'd like to see that solved. This seems like a good way to do it. I think there's a question of venue potentially of like, we don't necessarily have EAP experts here. And so is this something where there's, coordination across different groups and which group does it live in? So that's something that chairs, et cetera, would want to do, but I think we should be done somewhere. I think, as you point out, there's a lot of mapping to the auth scheme and a lot of similarities. I think one of the things we saw earlier was things like extensions that are using other parameters. And I think one of the values of having the work be done here is that we can make sure that things like extension mechanisms are able to work both for auth scheme as well as something like this, as far as how the design works. And also there's a very serious issue. I think you should change the naming because PPT is like privacy pass token, but all of the actual auth schemes call it just private token. So we should just be EPT.
Hi, my name is Sasha. I'm a PhD student at MIT. It seems like what you're building is really an anonymous credential, and you're kind of using Privacy Pass. Privacy Pass is a kind of a simplification of more general anonymous credentials. And so I was curious, like, now you're kind of extending this to a more like authentication setting. And so I was wondering how it would relate to like the rich field of anonymous credentials more generally.
Not sure I get that. Do you? Yeah.
Take it to the list.
Yeah.
It's an interesting question. Is this just a transport mechanism for another?
I think like, I think it's an important point because you're like, I see this as an intermediary where you kind of have an existing credential and you're trying to get the user access to the network without attesting to that entire credential. So you're really just trying to turn that rich credential into a Boolean or maybe a Boolean with some metadata. Yeah, and that's a common pattern you'll see apply with Privacy Pass.
So we're over time. Thank you very much for your presentation and thank all of you for staying a little bit extra to finish off this conversation. We'll see you on the list and then hopefully also in Dublin. A little bit over.
I figured it was all right.
Yeah, I mean, people seem